this example, or series of examples, we're going to look at how to expand a logarithm from a single logarithm into multiple logarithms using the same properties that we used a second ago when condensing. The difference, my recommendation is to use them in a different order. First, I would recommend taking advantage of the quotient property. If you have a single logarithm of a quotient, let's go ahead and separate that as a difference of two logarithms right from the start. Once you've done that, look at those two logarithms. Do either of those logarithms contain a product? If they do, let's go ahead and separate those using the product property so that becomes the sum of two logarithms instead of the single logarithm of the product. And then finally use the power property. If you have powers on after what's inside those logarithms, you can take advantage of that property to move those exponents down to the front of their respective logarithms. So that's kind of a little bit of an outline. Let's look at a couple examples and see how that works. So let's say I have this logarithm. Maybe I have the base 3 logarithm of this quotient. Maybe I have x y squared over z cubed, like that. And I want to go ahead and expand that out into multiple logarithms. So the first thing I look at here is I say, okay, I have a logarithm of a quotient. I can use that quotient property to separate this into the difference of two logarithms. So this should first be equal to the base 3 logarithm of xy squared minus the base 3 logarithm of z cubed. So I took advantage of that quotient property and separated this into a difference of two logarithms. Now I look at each of those logarithms, and this first one in particular I still see as a logarithm of a product. So I'm going to use my product property to expand that into the sum of two logarithms. So that would become log base 3 of x plus log base 3 of y squared. And then, of course, bring down this log base 3 of z cubed. Finally, I can go ahead, got some cats fighting over here. Finally, I can go ahead and continue this by using my power property to bring this exponent of 2 down in front of its this logarithm and this exponent of 3 down in front of its logarithm. So nothing to do on that first piece. It's still just log base 3 of x plus this becomes 2 log base 3 of y minus this becomes 3 log base 3 of z. And we've expanded that logarithm as far as we can. Take a look at another example that could maybe be, I'm just trying to think of some things that might trip people up. So I'll change the example slightly. Go ahead and leave the base 3 logarithm there. Let's say this time I had log base 3 of x squared over yz to the 4th. So at first, a very similar looking example to the one before, but notice I put two things in the denominator, and this oftentimes causes students to make a sign mistake. So I wanted to address this. First, again, I will start off by using my quotient property. I have the logarithm of a quotient, so I'm going to go ahead and separate that as the difference of the two logarithms. So this would become log base 3 of the numerator minus log base 3 of the denominator, yz to the 4th, like that. Not too bad. Not really anything different. But now I need to go ahead and separate the logarithm of a product. Here I have the logarithm of a product. So I need to separate that into the addition of two logarithms. So this becomes log base 3 of x squared minus, now here's where the mistake usually gets made. A lot of times students just do this. They just put that minus sign there and they say, oh, this becomes log base 3 of y plus log base 3 of z to the 4th. Well, not quite the way I wrote it there, because you were subtracting this whole thing. So if this thing just broke into two pieces, you need to make sure that you're still subtracting those two pieces. So technically this would still need to be in parentheses until you distribute the negative into both pieces. So that this would become log base 3 of x squared minus log base 3 of y, and then that goes minus log base 3 of z to the 4th. Like that. Again, a lot of times students make that sign mistake and they end up with plus right here instead of minus when there are multiple pieces in the denominator. So I wanted to make sure I addressed that. Running out of room on the whiteboard there, so I'm just going to kind of take it, when I do my last property, I'm going to use that power property. I'm not going to rewrite the entire line. I'm just going to go ahead and move the exponents down. So this exponent of 2 here on the x squared can move down in front of that logarithm, so that becomes 2 log base 3 of x minus log base 3 of y minus this 4 on the exponent is going to come down in front of here to make this minus 4 log base 3 of z. Again, so the trick there is not forgetting to distribute the negative, making sure that when this the thing you were subtracting became 2 pieces, that you made sure you were still subtracting both of those pieces. Show one last example on this video to kind of make a recommendation of some things that, again, you don't have to do this, but this is how I would approach the problem. Keep it a little bit simpler. Let's just say I had the common log of 2x squared cubed, like that. My advice, first off, would be go ahead and simplify this here. Take advantage of your powers, of your exponent rules from Algebra 1 to take powers to powers and take products to powers like that, and rewrite this as log of 2 cubed times x to the 6th, like that. Again, I just applied this power to both things in the parentheses here, since this was a product. It's a 2 to the 3rd and x to the 6th. You could write 2 to the 3rd as 8 if you want. That would be fine. I'm just going to go ahead and leave it as 2 to the 3rd just to give me another opportunity to use an exponent rule. Now that I've done that, I see the logarithm of a product, so that should separate as the logarithm with the base 10 of 2 to the 3rd plus the logarithm, in this case, of base 10 of x to the 6th, using my product property. And then finally, I can use my power property to move my exponents down front to make this 3 log of 2 plus 6 log of x, like that. So I expanded that. I took advantage of some of my exponent rules at the beginning there. I certainly wouldn't have had to do that. I could have taken advantage of the power property right from the beginning and moved this 3 out in front, but then you're kind of in the same situation we were talking about there. As you separate this, you have to remember that that 3 is in fact being distributed in to both of the pieces, and a lot of times students will forget to do that. I hope this helps. Again, reach out if you have questions. Hopefully my 2 cats will stop fighting over there so I can continue to make some more videos, but until next time.